This is part 7 of LINQ tutorial. In this video, we'll discuss projection operators in LINQ. Select and select many standard query operators belong to projection operators category. Projection operators are used to transform the results of a query. Select clause in Transact SQL allows us to specify what columns we want to retrieve from the list of all available columns. In a similar fashion, the LINQ select standard query operator allows us to specify what properties we want to retrieve. It also allows us to perform calculations. Notice the employee class right here. It has got 5 properties: employee ID, first name, last name, gender, and annual salary. Using the select projection operator, we can select just the employee ID property, or we can even select multiple properties like first name and gender into an anonymous type, or even perform calculations like monthly salary and full name on the fly. Let's look at a few examples. Let's flip to Visual Studio. Here I have a new console application. To this project, let's add a new class file and let's name it employee.cs. To speed things up, I have already implemented the code required for this employee class, so let's copy and paste it right here. These are the properties that you have seen already on the slide, and then this employee class also has a static method called getAllEmployees, which is returning list of employee objects. And if you look at the implementation of this method, it's pretty straightforward. Here we have a variable of type listEmployee, and this list contains 4 employee objects, and finally we are returning that list back. So pretty straightforward employee class. I'll have this class available on my blog in case you need it. Now what we want to do is retrieve just the employee ID property of all employees and print them on a console screen. So let's see how to achieve this. So we're going to make use of the employee class, which has got this getAllEmployees static method, and notice that this method is returning list of employee objects. Now we don't want all the properties of the employee, we want just the employee ID property. So I'm going to use the select extension method and then specify a lambda expression which is going to retrieve just the employee ID property. So emp such that emp dot employee ID. Now this lambda expression will be applied on every employee object that is present within this list, and the type of this employee ID is an integer. So when I hover the mouse over this select extension method, look at the IntelliSense, it is returning I enumerable of integer, right? So let's use a variable of type I enumerable of int. Let's call it result. So this variable is going to store the list of all employee IDs, and then we can use a for each loop. For each int id in result, print the value of id. Let's run this. Notice that we get the employee IDs printed. So if you look at the list that we have, employee IDs start from 101 and go all the way up to 104. Let's look at another example. This time what we want to do is project first name and gender properties of all employee objects into anonymous type and then print first name and gender on the console screen. So let's see again how to achieve that. So getAllEmployees, again it's going to return that list of employee objects. This time we want first name and gender to be projected into an anonymous type. So we are using a lambda expression again, emp, such that what we want to do now is create a new anonymous type. So I'm going to use a new keyword. Now if we want to create a new customer object, we'll simply say new customer and then specify the properties and then populate them. But here an anonymous type is a type that doesn't contain any name, so that's why we are simply saying new, and then we don't have the name of the type that we want to create. Now again we need to specify the properties for this anonymous type as well. So the first property is going to be first name, and the value for this property is going to come from the employee object first name property. And the second property that will be present in our anonymous type is gender, and the value for that is going to come from the gender property of the employee object. And notice that at the moment we have a compilation error. That's because, look at the variable on the left hand side here, it's I enumerable of int, but then this select method, it's not going to return an I enumerable of int. If I hover the mouse over, look at what it is returning. Look at the first line in the IntelliSense. It's returning I enumerable of a. So what is a here? A, look at the second line here. A is an anonymous type which has got two properties, first name and gender, right? So if it is an I enumerable of customer object, for example, then we can say I enumerable of customer here, but the type that is being returned now, it doesn't have any name, so we can't really say what is the type of I enumerable that gets returned. That's why we have something called var. So this is now going to store the anonymous type. Okay, so that is I enumerable of that anonymous type that is returned by the select extension method. Now we can use this for each loop through the anonymous type. So again we have to use var keyword here, var, let's call it v in result, and now when I say v dot, we should see both these properties, first name and gender. So v dot first name, and then we also want to print the gender. Alright, let's go ahead and run this now. Notice that name of the employee and the respective gender is printed. So here we are projecting those two properties, the first name and gender, into an anonymous type. Let's look at another example. Now this time what we want to do is compute full name and monthly salary of all employees and project these two new computed properties into an anonymous type and then print full name and annual salary, monthly salary on the console screen. So how do we compute the full name? By concatenating first name and last name. And how do we calculate monthly salary? By dividing the annual salary by 12. So let's look at that example. So we want to select again an anonymous type. This time what we want is full name. And full name, how are we going to compute that? Employee.firstname plus, give a space, and then emp.lastname. Notice that here we are performing a calculation, and then we are storing that result in this property of the anonymous type. And similarly, what else we want? We want monthly salary. So monthly salary equals employee dot annual salary, divide that by 12. Okay, now these are the properties that are present in our anonymous type now. That's why if I look at this for each loop, we have compilation errors because first name is not present within the new anonymous type. So what we want to do, we want to print full name and then monthly salary. So now let's go ahead and run this. So notice that we get the employee full name and their respective monthly salaries. Let's look at one more example. Now this time what we want to do is give 10% bonus to all employees whose annual salary is greater than 50,000 and project all such employees' first name, annual salary and bonus into an anonymous type. Right? So to filter the employees, we are first using the where extension method. So we are saying where employee such that employee.annual salary is greater than 50,000, and then we are using the select extension method and then projecting an anonymous type here and then specifying what properties we want. So within the name property we are storing just the first name, salary we are storing the annual salary, and to compute the bonus we want to give 10% bonus to everyone who has got annual salary greater than 50,000. So 10% is 0.1. So multiply annual salary with 0.1. It's that straightforward. So we have to first apply the where extension method, and then we'll say where x such that x dot annual salary greater than 50,000, and now we apply the select extension method. So select emp such that what we want to do is we want the property to be named as name, and the value of that one is going to be equal to emp.firstname, and then we want annual salary. So let's make this property annual salary, emp.annual salary. And what else we want? We want bonus. So bonus equals emp.annual salary into 0.1. So now, whatever we get back, it's going to contain these three properties: name, annual salary, and bonus. So what we want to do is print name, separate that with a colon, and then we want to print annual salary, separate that with a dash, and then we want to print bonus. Now when we run this, we should see the name of the employee, their annual salary, and the bonus they get. 10% of 60,000 is 6,000. Okay, and look at that, it only displays now 3 employees because only 3 employees have got a salary that is greater than 50,000. Alright, that's it for today. Thank you for listening. Have a great day.